steady.
Amazing. Hello, Porto. My talk is about NPM on IPFS. We're going to go into some technical details, and we're going to see some demos, which is going to be super good fun. My name is Alex Potsides. I work for Protocol Labs. I am a core JavaScript developer working on the IPFS project. I am aching brain on most internets. You can find me on GitHub and Twitter. So, NPM on IPFS is a way to install your dependencies for your JavaScript project using the power of the distributed web. Cool, right? Who doesn't want that? So it's two things, it's NPM and it's IPFS. So who's heard of NPM? Like everyone, right? So NPM is the largest package registry in the entire world. It has over 850,000 packages and over 36 billion downloads a month. I mean, those are enormous numbers. Like, if you can judge the healthiness of a community by its registry stats, I mean, those are incredible. Like, NPM is big. IPFS. So who's heard of IPFS? That's pretty good. Who uses IPFS? Good, good. So what is it? It's a distributed shared file system that we use to build distributed applications, or the D-Web. Like, all of these things are going to become clear soon. So what is it? It's the interplanetary file system, because you have to aim big, right? So it uses content addressing, and it's a distributed file system. So what is content addressing? Well, sometimes you want a cat GIF, and the normal way that you would get a cat GIF is you would use a URL. So we all know what URLs are. They're location-based addressing. So you have a protocol, you have a host, and you have a path. But there are some problems with URLs. So one thing is you've got no guarantee of content integrity. So you can request a URL, and you could get back some completely different content from what you were expecting. Anyone who knows PhotoBucket and uses any kind of forum on the internet will probably recognize this image when they turned off their hot linking and swapped out all the images on these forums for this image. The routing is baked in. So you've got the name of the server that you're trying to contact at all times. And that means that that server, if it goes away, then you can't find another route to that bit of content that you're after. And they're easy to block, because your domain typically resolves to one IP address, or a selection if you're doing round-robin DNS. But it makes it very easy to block these things. So things like in developing nations, occasionally they block Wikipedia, which is kind of tedious. So the way IPFS deals with this problem is it uses content addressing instead of location addressing. So each bit of content that you have has an identifier, and this incredibly human-centric hash. So the identifier can be used to resolve content in the same way as a URL, but also to verify the content, because we can unpack these content IDs. So if we have a look at what the content ID actually is, so we have a hash of the data. So once we get the data we've requested, we can verify that it was actually the data that we requested. We've got a format and the multi-codec, and this tells us how to interpret this data. And then there's a version number, and then we've got the encoding. So this string obviously is encoded somehow. Like, you might look at it and think it's base 64 or something like that. It is base 58 BTC. We know this because the first few bytes tell us what the rest of the string is encoded with. So we have different versions as well. So this one is encoded in base 32. So I'll paste this one up here. And it's obviously hard to parse this as humans, but the hash for the content is identical for the different encoded string, which is lovely. So far, so dry. So it's distributed, right? You're going to see some images you'll probably remember from university. The one on the right, obviously, not the one on the left. So if you've got a centralized network, you have a single point of failure, and all the traffic goes into that single node. And if that node goes away, you have no network. If it's decentralized, we're getting better. So now we've got little islands of connectivity, and if this one goes away, well, these ones can still talk to each other, so that's quite good. But where we really want to get to is a distributed web, where all the peers on the network are equal. You've got multiple routes through the network is fault tolerant, and it's resistant to failure. And so if nodes go away, you can just route around them. IPFS, these are the technologies that underpin it. But how does it all work? So each file that you upload to IPFS gets broken into chunks. Every chunk gets given a content identifier, a CID, which is that lovely long hash that we saw earlier. The chunks are arranged into a graph, which is a directed acyclic graph. That is to say, the nodes are only connected in one direction. There are no loops in it. This is so a directed acyclic graph, which is a DAG. Daggy, dag, dag, dag. There are lots of DAGs. The nice thing about breaking the content down into little chunks and giving each one its own identifier is that you can deduplicate the content within your network. So if you have a file that has lots of continuous blocks that are the same, you can actually then have that file be stored in a very, very efficient manner. Each node on the network makes some or all of the chunks in a given DAG available, and the content gets distributed through the network. So the content that you're after will be replicated on lots of other nodes, so it makes it a lot more available. And the peers pass on the queries for content node to node. It's open source. It's an enormous open source project. There are hundreds of repositories, which is incredibly bewildering. Like sometimes it's very hard to find things, but they are there. They're all there, and they're all open, and we want help. We have over 3,100 contributors and almost 350 contributing every month. This is a massive project. You should, if you're interested in the distributed web, you should check out github.com/IPFS and get involved. But back to NPM on IPFS, what we all came here for. So NPM on IPFS is a commons registry. So it mirrors all of NPM onto IPFS. We use it internally to make sure that IPFS can handle terabytes and terabytes of data. And you can use it right now. So if you were to do npm install registry, and then the registry address, it's registry.js.ipfs.io. Yarn as well is supported. Cool. But how does it work? So what we have is a collection of nodes. So these ones are running the registry mirror, and they just connect to normal IPFS nodes. So these make the NPM content available on the network. They also listen to requests over HTTP the same way that the NPM registry does. It's all written in JavaScript. It takes an incoming request for a given tarball of a module and turns it into a content ID, and then uses IPFS to fetch that content. If the content is not there, it will actually go to NPM and get it, and then cache it in or add it to IPFS, so that next time someone requests it, it's there. So the user installs something, they make some requests for these URLs. So here we're installing the future tech version of IPFS, JS IPFS. And then one of these registry mirrors will take this request for a tarball, turn it into a hash, and then use IPFS to fetch it from the network. The way it does this is by having a copy of the module's manifest, which has a list of tarballs for given versions, and each tarball has a CID. If it doesn't have the CID, that's when we go to NPM, we get it, we save it in the manifest, and then next time someone requests it, we have it. So the reason that we have to do this translation is because NPM doesn't understand anything that isn't HTTP. It's the only transport that it uses. So we need to have some kind of translation. So when you're using it like this, just adding a registry argument, you're going over HTTP to IPFS, which obviously you can't do. So we stuck an Nginx on it, and that sits in front and proxies to all these nodes that are waiting. Like, how is this better? Like, is this better? Because we're still using HTTP, we're still using URLs. Like, have we actually improved anything? Like, or is it just a slower version of NPM? Like, I mean, the network is more available, so the content, because the content is cached redundantly across multiple nodes, there's more of a chance of you being able to fetch it if there's some problems with the network. That's an improvement. But apart from that, I mean, like, it would be better if you could skip HTTP entirely and just use IPFS to fetch your content. You can! You can! You can use IPFS NPM. Or NPM IPFS, it's both, because I can never remember. So it'll actually create binaries for both names. Then you can just use IPFS NPM install. Or IPFS yarn. Why not, if you use yarn? We're all friends. So how does this one work? Well, so again, we've still got HTTP, which is like tedious, but until NPM support multiple transports, that's all we can do, really. So on your developer machine, it will spin up a web server and basically do all that work that the registry mirror is doing on your local machine. So you end up requesting a local host address with a tarball URL, which then gets turned into a CID, which then leaves your machine and goes onto the IPFS network. Super cool. It keeps a local copy of everything, so you can use it offline. Which is great if you're on a plane or something like that. Demo time. All right. This has been very theory heavy so far. I do apologize. And if it's the first time that a lot of you are seeing IPFS, there's a lot of overhead. But cool. So here we go. So I'm in a directory. There's nothing here. I'm going to remove my cache. Clean false. I don't know what you know you're doing. I don't know what I'm doing. No one knows what they're doing. So if I make a project, and I'm going to IPFS NPM init. So it is a proxy for the package manager that you're using. So if you're not if you don't get the package manager to start making HTTP requests, it will just proxy everything through to the package manager itself. So we haven't re-implemented init or anything silly like that. It will just send whatever command you're typing off to NPM. So does some accounting. Okay, blah, 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 blah. Great, cool. So now we have a project. Cat package. Nice, empty package.json. So let's actually do something useful. So if I install save big number. So I'm using big number because it's quick to install, because it is a package that does some work, but it doesn't have any dependencies. So it starts your IPFS node. It tries to connect. Oh God, it's too big. It's too big. So what's happening here? So we start an IPFS node locally. We try to connect to the remote registry. The reason that it connects to the remote registry, again using HTTP, is because there's no DHT support in the JS IPFS. This will mean nothing to most of you, but it can't discover content easily. So we just kind of shimmed it in, but it's going to change, like, of the fantastic Christmas present. I don't know if I'm going to spoil it for Alan, but yeah, it's going to be amazing. It's going to be amazing. It's going to be so good. I'm so excited. You should be excited too. Cool. So anyway, so it connects to the registry, starts your local proxy, and then you can see your normal NPM output. So you can see, so this line here is the proxy receiving a request. This is the normal NPM output. So we've overridden the registry that it's using. It's on a local host. And it goes to localhost and gets it. Great. So I've got a package log file. Amazing. So there we go. So now we have a node modules folder. Big number installed. That's cool. Right. God. Let's start again and use yarn instead this time. IPFS yarn. Or like the other way around. Yarn. Oh no, what even is that? Oh god. Yarn IPFS. Yeah, other way around. Cool. So same thing. Starting our server. Oh god, so much faster. Wow. Love yarn. Cool. It's probably because I didn't clear the yarn cache. That's why. That's why. But yeah, so what's the other way around? 2 FS yarn. Blah, 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 blah. Boring. See that? It's cool. Okay, so nice. So it works. That's really good. But what if the internet went out? Should we look at it offline? I'm just going to turn off the Wi-Fi, and so everything is cached locally. So in theory, so if I remove my, oh god, it's still going. It's not that fast. What is happening here? Thanks, Yarn. I'm just gonna start a new tab. CD test demo. Bigger. Okay, fine. So if I go back into my project, what's happening? Go away. Oh, this is why you should never do demos. It's awful. I think it's working. So if I PS aux script. Oh god, what is all this? One of these things is a thing that is not dying. I'm just going to try it. It's going to be fun. Anyway, so npm IPFS install. So I've already got the package log file. Is there anything in my package? Cat package.json. Yes. So big number is there. So if I do npm IPFS install, I'm going to just turn off the request retries, because otherwise it will continue trying. It will time out eventually, but we don't want it to take too long, because this is a talk and not actual work. So there we go. I mean, so what's happened here? So we've started our node. We can't connect to the registry because we're offline. Great. And then npm starts firing requests. And then this one, it looks like an error, but it's not really. So at the end of a npm install, npm goes to npm and says, like, are there any security vulnerabilities in the packages I've just installed? That's what that is, and that's why it doesn't work, because we're offline. But node modules, big number, it's there. So we installed offline. Demo, done. Okay, cool. So when you start npm on IPFS running on your local machine, you are joining the IPFS network. That means that you can then start serving content to other peers, which is really, really useful, being a good citizen. So, I mean, only while you're installing the dependency, which obviously doesn't take that long. But anyway, so you are then a member of the network. So the interesting thing then is, like, how do you get new content? So obviously you are storing all the stuff locally, but you need some way of going off to npm and saying, is there a new version of this module? So what we have is a replication server that's sitting there taking in changes from npm and distributing. So there's some pub sub going on between these different nodes that says, hey, there's a new version of this module, why don't you go and get it? And so they go off and get it. And then it gets onto IPFS and becomes available for everyone. Super good. That is npm on IPFS. I mean, like, what next? So what would be amazing would be getting npm to add IPFS as a transport so that we don't have to have any of this stuff and you could just go straight to IPFS and get it. I mean, that would be incredible. If you could publish your module, so this is an interesting problem to solve because there's, obviously you need to be able to trust the person who's published modules very, very timely that thing. It's an interesting problem. Like, if you've got some ideas, we'd love to hear them. GitHub.com/IPFS is where you should put them. No central registry. I mean, if you're publishing locally and you have, like, here's my module, come and get it, and then obviously it will distribute itself through the network, but then you have no central point of failure again, which is great. Anyway, these are the kind of things that we're thinking about. If you'd like to help out, please do come to github.com/IPFS and help out. Thanks. That's me.